we want to solve this question writing. So we want to find out the values of n that of course is actually going to satisfy this interesting equation writing. And of course at the end of the day we should be able to get up to 6 values of n which will satisfy this problem. So you want to stick around even as we proceed in the solving. Okay, so what I'm going to do is actually to write this n power 6 as n power 3 raised to power 2 is equal to, I will also do same here, so this is 2 power 3 then of course raised to power 2. I haven't changed the equation because when you use this 2 to multiply this 3 right here, you're going to be having 6, and of course this is exactly what I did over here. So I'm actually going to subtract this item from both sides. So if I do that, what I'm going to be having is n power 3 all raised to power 2 minus 2 power 3 all raised to power 2 is equal to 0. And then at this point you can see we've got some difference of 2 squares, and if you can remember the expansion a power 2 minus b power 2, you can actually expand these as a plus b and then multiply by a minus b. So this is the expansion I'm gonna actually use to expand this stuff right here. So and in this case our a is equal to n power 3 and then our b is equal to 2 power 3. So expanding that is actually going to change to n power 3 plus 2 power 3, okay, and then multiply by n power 3 minus 2 power 3, and of course this will be equal to 0. For this equation to hold, for the product of these two terms to be equal to 0, is either 1 n power 3 plus 2 power 3 is equal to 0, or we look at the second case, that is case 2, where this 1 becomes true, and n power 3 minus 2 power 3 is equal to 0. So this is actually going to be the case that will satisfy for the product. Is either this is equal to 0 or this term is equal to 0. That's actually when the product is actually going to be equal to 0. Okay, so we're going to be solving these two cases. So let us solve this case 1 right here. So to solve this, you need to remember this expansion a power 3 plus b power 3. You can actually expand this as a plus b, and then of course multiply by a squared minus ab plus b squared. Okay, so and of course in this case you can see that our a is equal to n and then our b is equal to 2. So if I use this to simplify this, what I'm going to be having is n plus 2 and then multiply by n squared minus 2n and then plus 2 squared, which is equal to 4. Okay, so this will be equal to 0. So applying the 0 product rule again, we can see that n plus 2 has to be equal to 0, or this term n squared minus 2n plus 4 has to be equal to 0. So if this becomes the case, we can see clearly here that n will be equal to -2. So this will be the first value of n that will satisfy the problem we are solving. But if this becomes true, what we just need to do is apply the quadratic formula to solve this, where n will be equal to minus b plus or minus the square root of p squared minus 4ac and all divided by 2a. And of course in this case a, which is coefficient of n squared, is equal to 1, and b, which is the coefficient of n, is equal to -2, and c, which is the constant, is equal to 4. So substituting the values, we will have that our n will be equal to minus and then of course minus 2 plus or minus root negative 2 raised to the power 2 minus 4 times a is 1 times c is equal to 4, and all divided by 2 times 1. So if we simplify this, minus times minus is plus or minus root minus 2 power 2 is equal to 4, minus 4 times 1 times 4 is 16, and all divided by 2. Okay, so eventually what we have is 2 plus or minus root 4 minus 16 is minus 12, all divided by 2. And then we can go ahead to simplify this minus 12 right here. So we can do that as 12 times minus 1. Okay, all of this will be divided by 2. Okay, so continuing here, what we have is 2 plus or minus, we can actually split these as root 12 multiplied by root negative 1, and all divided by 12, and all divided by 2, and this will be equal to 2 plus or minus, we can actually simplify this root 12 here as root 4 times 3 multiplied by root negative 1 here, we know it to be a complex value I. Okay, so this is still divided by 2, so this will be equal to 2 plus or minus, so we can take the square root of 4 here, which is equal to 2, and then root 3. Okay, so we have 2 root 3 multiplied by this I divided by 2. So since 2 is common here, we can actually factor 2 out. Okay, bring it out here, so we have 1 plus minus root 3i, and all divided by 2. So this 2 can actually cancel this, and then n eventually becomes 1 plus or minus root 3i. So here you can see that we've got another 2 values for x, and then of course when we add it to the first one, we've got 3 values of n. So what we are going to do next is actually to proceed to case 2, which is here, and that is where we're going to be getting the remaining 3 values of n, which will give us the complete 6 values of n, which will satisfy the problem we are solving. So if we consider case 2, okay, where n power 3 minus 2 power 3 is equal to 0. So we just need to remember this algebraic expansion, a power 3 minus b power 3. You can actually expand this as a minus b, and then multiply by a squared plus ab, and of course plus b squared. And in this case, our a is equal to n and our b is equal to 2. So if we apply this rule, this stuff is actually going to change to n minus 2 multiplied by n squared plus 2n, then of course plus 2 squared, which is equal to 4. Okay, and of course is equal to 0. So just like we did earlier on, we have 2 cases right here. So it is either n minus 2 is equal to 0, or n squared plus 2n plus 4 is equal to 0. So if n minus 2 is equal to 0, n is actually going to be equal to 2, and this will form the 4th value of n, which will satisfy the problem we are solving. Okay, so if we consider this case right here, what we just need to do is apply the quadratic formula to also find out the values of n. So where n will be equal to minus b plus or minus root b squared minus 4ac, and all divided by 2 times a. Okay, and of course in this case our a, which is the coefficient of n squared, is equal to 1, b, which is the coefficient of n, is equal to 2, and c, which is the constant, is equal to 4. So if we substitute all of these values in n here, our n will be equal to minus 2 plus or minus root 2 power 2 minus 4 times 1, and of course times 4, and all divided by 2 times 1. And of course when we evaluate it right here, so this is actually going to be 4 minus 4 times 4 times 1, which is equal to 16, and then 2 times here is 2 times 1 here is equal to 2. Okay, so what we're going to be having is that n, so let me just put it right there before. So n will be equal to minus 2 plus or minus root 4, and then minus 4 times 4. So let me just write it as 16, all divided by 2. Okay, so continuing from here, n will be equal to 2 negative 2 plus or minus the square root of 4 minus 16 here is minus 12, and all divided by 2. And of course this will be equal to negative 2 plus or minus, we have actually simplified this in a previous solvings, and then we got this to be equal to 2, okay, root 3i. You can actually go through the previous steps and then see how we simplify this to be equal to 2 root 3i. Okay, so this will be divided by 2, and then from here you can see that we've got common term right here, so we can factor out 2, and when we do that we have minus 1 plus or minus root 3i, and all divided by 2, so that these 2 can actually cancel these 2, and then n becomes minus 1 plus or minus root 3i. Okay, so this is actually going to be the 5th and the 6th values of n, which will satisfy the problem we are solving. So if you followed through, the solutions to these interesting equations are n is equal to plus or minus 2, and then n is equal to 1 plus or minus root 3i, and then n is equal to 1 negative 1 plus or minus root 3i. Okay, of course you can see that this is a real solution, and then this 2 is a complex solution, and of course that is how you can actually solve for this kind of problem. And let me know if you've understood the solution in the comment section. Let me have your thought right there. And of course, if you've enjoyed the video, do not forget to like the video, share it with your friends, and then subscribe to our channel so that you stay updated each time we release new content. Okay, so thank you so much for watching, and I'm going to see you guys in my next video. Bye.